Hi everyone, my name is K. Prakash from CSM department. Today my topic is the characteristic of game theory. Introduction to game theory. Game theory is a mathematical framework for analyzing the strategic interactions among ration decision makers. It provides a way to model competitive situations where the outcome depends on the action of all participants. Understanding game theory is essential for optimizing outcomes in various fields, including economics, political science, and biology. Coming to the next slide, definition of optimization. Optimization. Optimization refers to the process of finding the best solution from a set of feasible solutions. In the constructs of game theory, optimization involves maximizing of or minimizing certain objectives. The goal is to achieve the most favorable outcome for one or more players involved in the game. Explain the characterization of a game theory in optimization technique. Optimization refers to the process of finding the best solution from a set of feasible solutions. In the context of game theory, optimization involves maximizing or minimizing certain objectives. The goal is to achieve the most favorable outcome for one or more players involved in the game. Coming to the next slide, key concepts of game theory. Importance concepts include player strategy, playoffs, and equilibria. Strategies represents their plans of action players may be to achieve their objects. Players are the decision makers whose choices impact the outcome of the game. Rules, strategies, playoffs, and equilibrium. Economic situations are treated as games. A player payoff is the amount that the player wins or loses in the particular situation in a game. A player has a dominator strategy if that player's best strategy does not depend on the what other players do. Coming to the next slide, types of games. Games can be classified as cooperative or non-cooperative based on the nature of player interactions. Cooperative games allow players to form collections and make blinding arguments. Non-cooperative games involve players acting independently, often leading to the competitive systems. Types of games: cooperative. A game in cooperative if the players are able to form binding communications. For instance, the legal system requires them to adhere to their promises. Often it's assumed that communication among players is allowed to cooperative games. Cooperative games focus on the game at large. In game theory, a non-cooperative game is one of the which players make decisions independently. Non-cooperative games are able to mod situations to the finest details, producing accurate results. Hyper games contain cooperative and non-cooperative elements. Coming to the next slide, Nash equilibrium. Nash equilibrium occurs when no players can benefit by unwittingly changing their strategy. It's a key concept in non-cooperative game theory that helps predict player behavior. Finding Nash equilibrium helps optimize the strategy in competitive environments. Nash equilibrium, a strategy profile is an Nash equilibrium if and only if each player's presented strategy it is a best response to the strategy of the others. Equilibrium that is reached even if it is not the best equilibrium. Coming to the next slide, a domination strategies. Types of domination strategy. A dominant strategy is one of the best yields a better outcome for a player regardless of the opponent actions. Identify dominant strategy simplifies decision making in optimization problem. Players will often prefer their domination strategy when aiming for optimal outcomes. Types of domination strategy. Coming to the next slide, mixed strategies. zero sum games. Zero sum games are situations where one player's gain is another player loss. Strategies in zero sum games often focus on minimizing losses while maximizing gains. These games are useful for understanding competitive scenario and optimization. Zero sum versus non-zero sum. If we cooperate, we both we know good idea, and if there is a much better, definitely. Coming to the next slide. Multiplayer games. Multiplayer games involves more than two players completing the analysis of strategy and outcomes. The interactions in multiple layer games require consideration of variations and dynamics and all analysis. Optimization in multiplayer games often refers on collation, formation, and strategic cooperation. Multiplayer gamer. Some players might be computer generated animations, distributed state representation. Coming to the next slide, applications of game theory in optimization. And understanding game theory can lead to better decision making in complex environments. Game theory is applied in various fields, including economics, finance, and operations research. It helps in optimizing pricing, strategy, resources, and allocations, and competitive binding. Coming to the next slide, behavior game theory. Uh, Behavioral game theory intercepted physiological insights into place decision making. It challenges the assumption of rationing in traditional game theory. This approach can these optimize outcomes by analogizing strategy which actual human behavior. Coming to the next slide, algorithm game theory. Algorithm game theory combines computer science and game theory to solve optimization problems. It focuses on designing algorithms that can efficiently compute optimization strategy. This field has applications in the network design, auctions, and online makers. Mechanism design is a branch of game theory focused on creating rules to achieve decision outcomes. It involves struggling games to enhance players to act in a way that ideas to optimization. Effective mechanism design can enhance cooperation and improve overall results. Challenges in game theory optimization. One challenge is the complexity of predicting player behavior and strategic interactions. Another issue is the potential for multiple equilibrium, making it hard to select an optimal strategy. Additionally, real world factors can complicate the theoretical models, impacting their applicability. Case studies analyzing real world case studies can demonstrate the practical application of the game theory. Examples include competitive business strategies, political connections, and resource management. Case studies provide enhances into successful optimization using game theoretical principles. Future directions. The future of game theory in optimization way involves more interactions applications. No development in behavioral instincts will development will depend understanding of human decision making. Advances in technology and data analysis will enhance modeling capacity. Conclusion. Game theory offers variable insights into optimization strategy in competitive environments. Understanding in characters is crucial for effective decision making across various fields. By leaving game theory, investigations and organizations can achieve better outcomes in complex situations. Thank you. By K. Bhanu Prakash from CSM department.